Hello, everybody, and welcome to We Measure the World, a podcast produced by scientists for scientists.
I think one of the hardest things we ran into was when we were initially designing this research plan and kind of deciding what data we wanted to collect, deciding what sensors we wanted to use, where we wanted to install them, is that there is so much heterogeneity and variation within the solar array, even just within a single block of panels, across even just a couple feet apart because of these different zones. And it was challenging to balance, okay, what can we feasibly measure and how much data can we feasibly collect, while still capturing enough of this variability to actually be accurate and to have representative data.
That's a small taste of what we have in store for you today. We Measure the World explores interesting environmental research trends, how scientists are solving research issues, and what tools are helping them better understand measurements across the entire soil-plant-atmosphere continuum. Today's guest is Taylor Bacon, a Ph.D. student in the Department of Soil and Crop Sciences at Colorado State University. She obtained her bachelor's degree in chemical and biological engineering from Princeton University with a focus on energy and the environment and a minor in sustainable energy. Now, as a part of her PhD program, she's researching nature-based climate solutions, land use emissions, and food energy systems. And today she's here to talk about her research into agrivoltaics, regenerative energy and land use, and much more. So Taylor, thanks so much for being here.
Thank you so much for having me.
So today we wanted to talk with you about your projects and research interests. So can you tell us a little bit about your background and how you got into to where you are now with environmental sciences and into your specialty and your PhD research here?
Yeah, so as you mentioned in the intro, my background is actually in engineering. I did my undergrad in chemical and biological engineering, focusing on sustainable energy. And my undergrad thesis was looking at bioenergy for jet fuel production as kind of a sustainable alternative. But my senior year, I took an environmental policy class and really just had this moment of being like, oh, this is what we need to actually make these technical solutions I've been studying and work on happen in the real world. And we can be doing the research, but if there isn't the policy to actually drive that into implementation, that's kind of a missing piece. So I got really interested in environmental policy, and after graduating, got a fellowship at an environmental nonprofit working on climate and clean air and energy policy, and spent a couple years doing that. And it was really, really valuable experience. I learned a ton and kind of developed an understanding of how all of these drivers work together and kind of what actually has to happen for change towards a sustainable climate future. But after I was there for 3 years, and towards the end of my second or third year, I started really missing science and kind of more quantitative work. I was doing a lot of policy analysis and advocacy, but kind of was itching to get back towards the more quantitative side of things. So started thinking about what I wanted to do next and had a couple criteria. I wanted to do something where I could do field work outside and physically be collecting data and kind of be more on the ground, at an actual place collecting actual data after doing a lot of kind of modeling and high level analysis. I wanted to do something that was really solutions oriented. So I wanted to be doing science, but I wanted to be working on science that was kind of directly applicable to these problems we're facing and was really solutions oriented. And then I had taken a bunch of environmental chemistry classes in undergrad and started kind of looking in that space and found my way to this soil science program that kind of matched all of those criteria. And this project specifically that I'm working on in agrivoltaics is really exciting because it kind of matches my background in sustainable energy and energy policy with this soil ecology, biogeochemistry side of things that I'm more recently getting into.
That's awesome. That's super cool. I want to touch on all of that. So, but yeah. So can we go back? You'd mentioned that in your undergrad research, and I definitely want to dig into what you're doing now. That's going to be the bulk of what we want to talk about today. but you talked about working with biofuels and doing research in that aspect. And you said biojet fuels. That's something that I am not too. I'm familiar in general with biofuels, but not biojet fuels. Can you tell us a little bit about that and how that works? With jet fuel, that's a very it needs to be very high quality and a lot of other things like that. But can you tell us a little bit about that?
Yeah. So this was a while ago, so I'm a little removed from the weeds, but
Right.
the idea or kind of the motivation for this project was that we can electrify a lot of things, and electrification is a really good option for decarbonizing a lot of different sectors of the economy and a lot of different modes of transportation. But large scale electric aircraft are probably pretty far down the line.
Hmm.
But in the meantime, we have technological options for creating jet fuel from plant residue, from different plant based sources that when you're growing that feedstock, you're sequestering carbon. So the idea is that then your biojet fuel is carbon neutral because the emissions that are released are balanced out by the carbon that's sequestered when the plant's growing.
Hmm.
So my thesis was using a chemical engineering modeling software to design and model a pathway for converting. I looked specifically at forestry residue as kind of a sample feedstock that has maybe a little bit better sustainability on the front end because you're not displacing agriculture or kind of
Hmm.
it's this material that's already there. And there's definitely limitations in collecting it and accessing it, but that's what I used as my feedstock and then designed and modeled this process in this modeling software for converting it to a jet fuel
Right.
that in theory could be used as a drop-in jet fuel in existing infrastructure. Um, but did an economic analysis and was basically like, this is not feasible unless you have really ambitious carbon credits and a lot
Right.
of
Right.
policy support, which kind of tied back into the turning of my attention to environmental policy.
Right. So with that, I would assume that if you have an undergrad at Princeton who is interested in this stuff, that I'm sure there's plenty of other organizations and corporations that are dealing with biofuel research and those kinds of things. How did that tie into what the existing research and kind of research and development has been doing in that field?
Yeah, it was actually really great because there was a company actually based in Oregon called Red Rock Biofuels that were just starting to try and design and build and implement. I think the plant was maybe just starting construction when I was working on my thesis for a very similar pathway. So I got to connect with them and chat about their work a little bit. And then there's a biojet, or not a jet fuel, but just a biofuel plant in Iowa that's one of the only commercially operational ones in the US, I believe, or at least was at the time. So I got funding from Princeton to go tour that plant and kind of see what they were doing. So I definitely, yeah, did my best to kind of see what was actually happening and kind of where this fit in with what other people were doing. And there were
Hmm.
definitely other companies that were kind of starting out on the same path that I was looking at, and were definitely ahead of what I was doing because they were actually building a
Right.
plant rather than just modeling it.
Right. Right. So is that something then? I guess probably not in the commercial space, but are there then? Aircraft jet engines that are running off of biofuel or like mixed or hybrid fuels.
I think United has been doing a lot on sourcing their jet fuel and incorporating biojet fuel. So it's definitely a pretty small fraction, but there are a lot of people working on kind of setting targets and moving towards having it be um, more prevalent. And I think there are some airlines that, as kind of a way of supporting these pretty young technologies and young plants, will agree to buy a certain amount of biofuel, and that can kind of serve as a financing guarantee to actually get these things off the
Hmm.
ground.
That's awesome. That's cool. Oh, that's fun to see. It's one of those things where, well, I think a lot of what's interesting with what we're going to be talking about today and with your research is that there are a lot of things that we have that are going on right now, that do have that huge potential for greater impact when it comes to the environment and the climate and lots of other things that are tied to those as well. So I think that's really interesting. So you went from doing kind of more of the hard science research. You said that you went into policy and kind of environmental law, environmental policy, those kinds of things. What made you want to switch from, and you said you switched back, but what made you want to really get in and dig into environmental policy? And you started working with the Environmental Defense Fund there, that's based out of DC. So how did that change in trajectory happen for you?
Yeah, I think there were two big pieces. The first was the environmental policy class I took my last year at Princeton, and my the professor teaching that class had worked at the EPA and been really involved in the Kyoto Protocol, and it was really, really powerful to hear her experience as a scientist being involved in this really important policy. And just kind of made me start thinking about, okay, well, we have the technical solutions, and a lot of times that's not the limiting factor. Like, we have the technical know-how to do a lot more than we're doing currently. So, like, why is there this gap? And that class kind of was like, okay, well, there's all of these regulatory networks and frameworks and policy kind of support that needs to be there for these things to actually be making a difference. And I graduated during the Trump administration, and all of these kind of climate things felt like they were falling apart. And my feeling when I graduated was that, like, I don't want to be doing research kind of isolated from what's actually going on. I want to be working on solutions and kind of actually implementing these things. And tied with my thesis that we were just talking about, I had designed and modeled this pathway and kind of said, okay, these are the carbon emissions, this is the benefit, but it's not feasible unless you have this really strong policy support. But yeah, between my thesis experience and this class I took, I was just really eager to do something that was kind of more on the ground. And a friend sent me the listing for this fellowship at the Environmental Defense Fund and kind of said, this seems like it would be up your alley. And I was, very excited to have the opportunity to kind of see what was going on in the policy world. And I started out in DC, and it was super incredible to be going to congressional hearings and testifying at the EPA and really kind of be in the middle of the environmental policy world and see what it actually meant to have policy that supported these technical solutions.
So you actually got to be there communicating. So it seems, and you can correct me if I'm wrong, so you were working behind the scenes with doing research as well as kind of not necessarily creating policy, but suggestions and guidelines for policymakers, and then being able to communicate that to I guess the decision makers potentially as well. Is that kind of what your roles were there?
Yeah, I did a lot of research on policy and different policy options, and then I worked on a team that was predominantly lawyers who were involved in EPA regulatory action. So it was a lot of writing comments and kind of staying involved in these EPA processes, which are designed to have a lot of public feedback. But most people don't have time to read these super extensive dockets and submit comments and testify. So EDF did a lot of that work and kind of pushing forward these regulations in a way that would help climate and energy and air quality.
I think that's something that, it ties into some themes that we've had with a lot of our guests when it comes to kind of your different roles, your varying roles when it comes to scientific research, where you have the different ways that you're trying to communicate your findings or your understandings, or even just communicating the data or your interpretations of the data. Did you feel that it was? Let me back this up. what were the differences that you felt in being able to communicate, whether difficulties or, ease of communication when it came to communicating within, the research world versus communicating with policymakers versus even communicating with a general lay audience, if you had the opportunity as well?
Yeah, I think there's a lot of overlap in that the your goals for the communication are tailored to your audience,
Mm-hmm.
but you are still making very intentional choices about how you're communicating, what information you're including, how you're framing it for that audience. So I think the skill of like honing a message for an audience was really applicable across the range of people you're talking to. Um, I think learning to communicate for to the general public for kind of a more broad audience was really helpful. I think science communication, when you're in the weeds and you're kind of really getting into the meat of an issue, is almost easier because you can just kind of say everything that you know. But
Right, right.
for the general audience, it was a really helpful exercise in thinking about, okay, what's the most important thing? Like, how can I make this relatable or make it clear that this is important? Why is it important? And I had the opportunity to write blogs for EDF a lot,
Cool.
which was, yeah, great for my writing skills and my
Mm-hmm.
communication skills. And I definitely have carried a lot of those into my PhD program.
That's awesome. Yeah, that's definitely something that um, I think. I mean, everybody can work on communication skills, right? Whether it's interpersonal, whether it's to larger, broader audiences as well. But especially in dealing with those in the scientific research community, or research and development or whatever, and being able to really, I think, really hone in on what it is, not only what you want to convey, but yeah, what your audience, who your audience is, like you said, who your audience is, um, what kind of what kind of level are they going to be able to really grasp the your findings, your conclusions, or the I guess the direction that you want that conversation to go as well. I think that's again that's something that is it is key for anybody who's in the sciences to be able to communicate to a broader audience, not just within their bubble of academia or whatever it may be. So from there, how long were you at EDF?
I was there for just shy of 3 years.
Just shy of 3 years. So again, switching. What made you want to switch and move again from the world of DC and policymaking and other things back into kind of the hard science and research and back into academic research?
Yeah, when I finished my undergrad, I kind of was of the mind that I was never going back to school. I had had
Mm.
enough. I was just ready to be in the real world. Um, and then after a couple years at EDF, I loved my time at EDF and had such incredible colleagues and learned so much. Um, and I think I always was like, oh yeah, environmental policy is really important, and then kind of saw what it actually meant and what environmental policy looks like when you're actually implementing it. Um, but I just missed the more quantitative side of things. I was doing a lot of writing and kind of softer research, like reading a lot of policies, looking at policy impacts, but was working with consultants who were the ones who were doing a lot of the more quantitative work and analyzing
Mm-hmm.
outcomes of different policies a little more quantitatively. And EDF is a really unique organization in that it has a lot of PhD scientists on staff who are doing research, but um, in a way that is kind of focused towards policy relevant research, and really solutions oriented. And I was part of a early career scientist mentorship program at EDF and was paired with a really incredible climate scientist, and had the opportunity to hear about her experience as a PhD scientist. And she actually did her PhD at Princeton. So it was fun to chat about New Jersey.
That's cool.
But yeah, I think the combination of kind of feeling the itch to do something a little more quantitative and seeing these role models who had this mix of the science and the policy that I was really interested
Mm-hmm.
in,
Mm-hmm.
made me reconsider my initial stance that I was never going to go back to school, and start looking into grad school programs where I could hopefully work towards a similar career path.
Right, right. Thinking long term end goal. So is that something that you would like to do when you're done with your PhD work? Is to kind of move back into the policy world?
That's the goal. Something I mean, I still want to be doing research, and have that be a really central part of my career, but I really admire the scientists who are both scientists and advocates, and are doing really important science, but don't stop there and kind of move that science forward towards, like, this is how we can use this is what it means.
Mm-hmm.
So yeah, something like that, either at an environmental nonprofit or government agency, or something like NREL, the National Renewable Energy Lab, where they are doing a lot of really policy relevant research.
Mm-hmm.
That would be the dream someday.
Good, good. Well, good luck with that. So what took you then? What drew you to Colorado State University, where you're at now?
So I had been living in Colorado for the last 2 years of my fellowship at EDF. EDF has a Boulder office, and I'm from New Mexico originally, so it
Mm-hmm.
worked out well to be a little closer to home and in the mountains with lots of good trail running. Um, so I was looking at a pretty narrow set of schools to begin with, and CSU has a really incredible kind of soil ecology, biogeochemistry school or departments. And there's a lot of faculty, including my advisor, doing really incredible research in that space. And I reached out to a bunch of professors at a bunch of different schools and just had a lot of conversations about people's research, and ended up finding Keith Postian at CSU. And he had this agrivoltaics project that seemed like it was a really good fit for my background, and everything just kind of fell into
Mm-hmm.
place.
That's awesome. Um, Really quick, do you miss the humidity of back east?
No, I do not miss the East Coast. A lot of my friends are there, so I go back to visit. But growing up in New Mexico, like, 20% humidity was a humid day, so it was definitely an adjustment, and I
Yeah.
I do not miss it.
Um, so with your aside from your project, and we'll get to that next, were you able to kind of mold your coursework that you've been working on, and your program itself around this idea of I guess either renewable energy, regenerative energy, those kinds of things there?
Yeah, that's been one of my favorite things about a PhD program in general so far, is that there are effectively no requirements, and every course that I choose to take is just kind of working towards what I'm interested in and what my goals are. And I actually have the opportunity to be part of this very, very cool fellowship program at CSU, that's funded by the National Science Foundation and is called Interfuse, which is the interdisciplinary training, education, and research in food, energy, water systems. So it's
Hmm.
this really interdisciplinary group of students from all over the university, studying food, energy, water systems, and kind of a climate future, which is
Mm-hmm.
kind of exactly where I want to be, especially with the food, energy, intersection. And there's specific coursework that goes with the fellowship that's focused on the kind of systems thinking and systems analysis. And you're taking these classes with people from totally different backgrounds,
Mm-hmm.
totally different research. So
Mm-hmm.
that's been really, really valuable from a coursework perspective. And then starting to take a lot of the more soil ecology, biogeochemistry classes, since that's not something I have as much background in. And yeah, it's just been really great to be able to kind of pick the types of classes, from the big systems level classes to the what is happening on a tiny, tiny molecular level in the soil,
Mm-hmm.
and kind of bring those all together in this research project.
That's really cool. I have a soft spot for interdisciplinary research and fellowships and those kinds of things. I was a part of one back in my day, and it was really, really cool just being able to, because a lot of times we kind of get in, and this goes for anybody. I mean, any of you in the audience who's listening to this, like we often will get into our own bubble of, and we think, yes, the work that we're doing is really important, and it may very well be. But there's so many other people that are thinking about things that might be tangentially related or even overlapping with what you are interested in, that are thinking it, coming at it from a different perspective, or even, even might have different ideas, or even just the fact of being able to look at a problem with, different sets of eyes, is really important to being able to, solve problems and come up with solutions for a wide variety of different interests. So I think that's really cool, and I'm definitely an advocate for interdisciplinary research and collaboration, from whatever it may be, because there are things too, and I'm sure that you've seen it. We can talk more about this, about your project, about working with renewable energy, but then also you're incorporating the interests of ranchers and of other folks who have different different motives in mind potentially, but all coming together to try to make things better for the population as a whole, but starting small and working big. So I'm really happy that all that is going on for you. So let's jump into to this main project. Is this your dissertation project, or is this kind of a precursor to it?
This is it. This is the dissertation project.
This is the big one. All right, cool. So just talk to us a little bit about cattle tracker and about agrivoltaics, and we want to get into regenerative land use management and all that kind of stuff. So wherever you want to start, feel free to jump in, and we can go from there.
Yeah, so I have the opportunity to work on a very cool project called Cattle Tracker. It's funded by the Department of Energy Solar Energy Technology Office. And you were talking about interdisciplinary teams, and that's one of my favorite things about this project is, so broadly, our goal is to design a system to co-locate regenerative cattle grazing with solar energy generation. There's been a huge build out in solar energy, and there needs to be a lot more to stay on track with climate goals. But there's often a lot of tension around land use because solar requires so much more land than a like point source, like a coal-fired power plant. So figuring out where these solar power plants are going, a lot of times they're displacing agricultural land, and that can have drawbacks. So in the last decade or so, there's been a lot of research that is kind of questioning the idea that you can only do one or the other, that you have to do agriculture or solar energy generation. And it's often referred to as agrivoltaics, so the co-location of agriculture and solar photovoltaics. And the research has looked at all sorts of different combinations, so everything from growing high value vegetable crops to pollinator habitat to grazing, which is what we're focusing on. And because it's such a complex system, you have the animal side of things, you have the solar energy generation side of things, you have all of these ecosystem and ecological impacts. The team that we're working with on this project has folks from Silicon Ranch who are the principal investigators, and that's a solar company that is actually practicing solar grazing agrivoltaic systems and owns tons of solar power plants across the country, and kind of know the engineering and operations and management and maintenance side of things really well. And then we have on the CSU side of things, we have people who are working on biogeochemical models of what's happening and how the panels and the cattle and the soil and the vegetation is all interacting, and what's happening beneath these panels. And we have animal welfare experts who are looking at, okay, like what does this mean for the cattle? How are they
Hmm.
interacting? We have our field site is located at a ranch called White Oak Pastures in southwestern Georgia. So we have a lot of the ranch staff who are actually managing the sheep and cattle that we're studying. So there's all of these different people from all of these different backgrounds working towards this goal of designing this cattle compatible solar system, which is really exciting.
That's super cool. Um, so, I mean, there's lots of different ways we can go with this. I think let's take I guess let's take a step back and talk about, because you were talking about how solar farms use a lot of land. I guess what is kind of the baseline for solar farming right now uh, when it comes to solar panels and their footprints on the landscape. And I guess and then if you could talk about that as well as the environmental impact from, because a lot of times as we're dealing with counteracting and mitigating climate change, we want to delve into renewable energy, which then, I mean, solar is one of those primary energy sources. But at the same time, there are other environmental impacts from renewable energy sources as well. If you could just kind of dig into that a little bit there.
Yeah, I think that's really important. And that was one of the things that I was really excited about this project because at EDF, I'd been working on all this modeling and analysis and policy design that was like, okay, if we want to reach this percent reduction in carbon emissions by this year, this is the amount of solar we need. And it's one thing to say, okay, we need however many megawatts, gigawatts of solar. And it's another thing. My partner spent a summer working as a engineer on a solar power plant, and I went and visited him, and just seeing how big this solar power plant was, that was just like a fraction of the total that we needed.
Mm-hmm.
And it totally alters the landscape. I think the land where this one had been built had previously been cornfields and now is just kind of a mud pit. And
Mm-hmm.
there's different solar companies do it differently, and there's different impacts. And I think your question about what the impact of these solar power plants is something that people are like actively studying right now, and there's studies that are
Mm-hmm.
just starting to come out on kind of how the panels change the dynamics, and a lot of that depends on what vegetation you're planting and how you're managing the vegetation. So there's a lot of variables that impact what solar panels are doing to the ecosystem and to the environment. One of the big motivations for this project is how can we do it better? Like how can we minimize any negative impacts and maybe even have some positive impacts by pairing the regenerative grazing with the panels and hopefully improving soil health and vegetation productivity
Mm-hmm.
and indicators like that.
Right.
Um,
Yeah, I was going to say, could you go into a little bit more detail with those impacts? Because I mean, my assumption is that we're creating heat islands in these situations, or we're affecting that the microclimate there in that location, and we might say, oh, it's just a couple acres or half an acre or whatever it may be, but then again, you get the butterfly effect, and so you have these small little microclimates that then affect the regional climate around it, and other things like that.
Yeah, so the panels are really interesting because you take this pretty homogeneous landscape, everything's getting the same sun, everything is getting the same water. And then when you install the panels, all of a sudden it's very heterogeneous, and
Mm-hmm.
you have shading over certain areas and kind of redistribution of water as water flows off one side of the panel or the other. And some
Right.
areas aren't
Right.
getting rain, some areas aren't getting or are getting more rain than they would if it was just open because of the runoff.
Mm-hmm.
Um, and air temperature is affected. It's kind of buffered from broader air temperature swings by the panels, is what a lot of research is starting to show.
Mm-hmm.
There's been a couple papers suggesting that you maybe get some heat island effect, and there's a little bit of overall increase in air temperature, but I think that's also very climate dependent, and looking at, okay, what's the vegetation, because having plants under the solar panels can actually cool them down a little bit,
Right.
and
Yeah.
increase the efficiency of the panels. So I think the overall impact is really ecosystem dependent because you have the interactions of all of these different factors, and it's going to look really different in a hot, dry, arid climate than it is in a more wet, humid climate. So I think we're just starting
Hmm.
to get to the tip of the iceberg on kind of what this looks like
Right.
across different climates, across different regions.
Right. And so as part of this project, are you looking at different crop cover then, or different vegetation and plant cover there beneath the panels, and then at the same time, I think there's something that mentioned about looking at different, whether different types of crop cover, whether it's grazed, whether it's mowed, whether it's left just to grow on its own. What are your assumptions or hypotheses within that level of things?
So, for the first 2 years of our study, before we get to the goal of actually building and testing a cattle based system, we're doing all of our measurements and experiments in an existing solar power plant that is currently grazed by sheep. So, we're focusing on comparing vegetation management by sheep versus vegetation management by mowing, and then we have a control that's just grazing without any panels.
Mm.
So the vegetation cover and the soil characteristics are pretty comparable across all of our treatment areas, and we're really just looking at the management impacts. So how grazing versus mowing kind of changes what's going on, and hopefully something about how kind of the panels change the
Hmm.
ecosystem and the microclimate.
Right. So is this something then I was thinking, so we're talking about sheep, a lot smaller than cattle, have different grazing behaviors as well. And is there potential down the line to compare different types of livestock when it comes to grazing patterns and the effect on the solar farm there?
Yeah, I think there definitely is. And I think this study sets us up well to do that because we're establishing baselines with mowing and with sheep grazing. And for the cattle system, cattle are a lot bigger. There's a lot of concern about damage to
Hmm.
panels. So we have the branch of our project team that's looking at the ecosystem impacts, soil carbon, stuff like that. And then we have another branch of our team that's actually focused on the design of a cattle compatible PV system. So we have the animal welfare experts and the engineers who are
Hmm.
actually trying to design a system. But because nobody's grazing solar panels with cattle yet, because those systems just don't exist, there isn't a way to do a comparison yet. But hopefully by the end of this study, we'll be able to start looking at different species grazing comparisons.
Nice. So how would you consider or what would you do to say this is a successful project? Um, what would that look like?
So I think kind of from our project standpoint, one of our big goals is having this cattle tracker system actually be operational. So
Mm.
having a 250 kilowatt outdoor test lab, functioning solar panels with cattle grazing the vegetation beneath the panels. So that's kind of one of the big goals. But I think ultimately anything we learn from all of this data we're collecting will still be incredibly useful. And because it's a relatively short study, we probably won't see huge changes in things like soil carbon or
Mm-hmm.
um, other soil in particular changes very slowly. But I
Mm-hmm.
think we're establishing a baseline which sets us up to come back and resample and see how things change over longer periods of time, and gives us kind of initial comparison data. And I think in particular, we're collecting a lot of vegetation samples and seeing how vegetation productivity changes under these different treatments over the course of a growing season. And I think all of that data will be really helpful for informing decisions about how you manage vegetation under solar panels and what the impacts of grazing compared to mowing, which is a lot of times more standard, are.
You talked about collecting data, and what are the specific data points that you're getting? You've mentioned, you want to see how, water infiltration into the soil looks. You want to see how, potentially down the line about, carbon sequestration within the soil, or just the effect of the plants themselves and how they're thriving or not. And then also the microclimate around those. How are you measuring? How are you getting each of those data points? How are you measuring it? What are you using to measure it? And what are you seeing or expecting to see?
Yeah, so this is another thing that I think is really exciting about this study is we have a lot of different types of data we're collecting and a lot of different methods we're using. So we just finished our first field season this spring, spent a couple weeks out in Georgia at our field site collecting data. And on the ecosystem side of things, the primary things we were working on is we took a bunch of soil cores and collected the soil samples at different depths across the different zones. So if you imagine the panels, there's the drip edges, there's directly under the panel, there's between the panels. So in addition to kind of overall effects under the solar array, we're really looking at spatial variability and how the microclimate changes what's going on in the soil and with the vegetation. So we took soil samples across all of those zones. We took vegetation samples across all the zones, so we can look at how much vegetation is growing, what the functional groups are, so what kind of plants are there. And our partners at the ranch are continuing to take vegetation samples before and after every vegetation management event. So before a plot gets mowed or grazed, the team there takes a vegetation sample, and then after the event they'll take another sample, so we can kind of track how these vegetation management practices are influencing biomass productivity. And then we also installed a bunch of microclimate sensors. So we have soil moisture and temperature probes at 3 different depths across all of our sites. And then we have a bunch of microclimate sensors, so little weather stations measuring solar radiation, precipitation, air temperature, wind speed, which we expect to have a lot of spatial variability in all of those different variables. And I actually remembered what I was saying earlier. All of this data that we're collecting is also going to feed into a biogeochemical model. So trying to capture, there's a lot of ecosystem models that model plant growth and soil dynamics and carbon fluxes. And the goal is to integrate solar panels with grazing into those ecosystem models. So even if we don't have long-term data, we can still use this data to parameterize the models and hopefully say something really interesting and kind of play out different scenarios with these dynamics. So we have a bunch of the different sensors and samples that are now back in the lab to be analyzed. And then in addition, we're working with a team from the UK for a company called Quantera, and they installed eddy covariance flux towers at each of our treatments. Nice. So we'll be measuring, it's very, very exciting to have that data too. So we can see carbon and water fluxes from our site and hopefully pair that with all of the vegetation and soil and microclimate measurements and kind of see how the system as a whole is working.
That's super interesting. That's exciting. Yeah, that's fun to hear. What challenges or roadblocks have you had so far in this project?
I think one of the hardest things we ran into was when we were initially designing this research plan and kind of deciding what data we wanted to collect, deciding what sensors we wanted to use, where we wanted to install them, is that there is so much heterogeneity and variation within the solar array, even just within a single block of panels, across even just a couple feet apart because of these different zones. And it was challenging to balance, okay, what can we feasibly measure and how much data can we feasibly collect while still capturing enough of this variability to actually be accurate and to have representative data. And when I first submitted, I was like, okay, we need 81 TDRs to measure soil moisture. And RPI was kind of like, why do we need that many? Like, that's a lot. So kind of finding that sweet spot and being like, okay, this is going to give us enough data to do the things we're trying to do while still being feasible to actually implement. We only have so many people to go out and hammer soil cores into the ground and to install all of these sensors. So, and as a scientist, you always want like the most data you can get and
Yep.
like the highest quality, and accepting that like sometimes you just have to bank on what's feasible, and kind of as long as it meets what you need, and kind of step back and be like, okay, this is going to be enough, even though I would love to have TDRs at way more intervals or something like that.
Yep. I think that's been a forever problem, and I'm sure maybe it'll get overcome in the future. But yeah, especially when you're dealing with spatial variability, and that's always one of the big questions that we get here. Is like, okay, yeah, how many sensors do I need in order to? And it's like, it depends on your project, it depends on your questions. But yes, we want sensors everywhere. We want to be able to gather data from every single point. But like you said, that's not feasible right now. And at the same time too, I mean, it does make it can make your models more robust. But again, it's one of those things where sometimes as you're modeling, there's diminishing returns with the amount of how much you parameterize your models and how many variables you input. And so like you said, it's finding that sweet spot of making things work, especially depending on your budget as well. So as we're wrapping things up, can you just kind of give us an overview of your thoughts on the impact or implications of your project here, but also potentially the future of this kind of research into agrivoltaics and this combination of renewable energy and land use?
Yeah, I think this field is really exciting because, in my mind, there's not really any question that we're going to have a lot more solar and that there's going to be a lot of land that has solar installed on it. There's a Net Zero America study that Princeton did a couple years ago that looked at the footprint of energy we would need to meet a net zero target by 2050. And in their kind of highest land use scenario, I think it was something like 17 million additional acres of solar power plants. So it's coming. The exact scale, I think, is kind of unknown, but I think there's going to be a lot, and we need a lot. But I think this field is exciting because it's really asking how we can do that as well as possible, considering not just the solar energy and the like energy generation carbon side of things, but kind of a more systems-wide analysis of what this looks like and how solar installations can be built and designed and managed to really improve ecosystem function rather than detracting. So I think kind of every agrivoltaics angle and each different agricultural component looks at this a little differently. But I think as a whole, the field is really exciting for kind of thinking about not just sustainable energy that's sustainable from a energy carbon point of view, but that's sustainable from the land it's on. And our cattle tracker kind of North Star is a solution that's good for solar energy generation, good for the land, and good for the animals. And I think zooming out and having that kind of systems perspective is something that's really great about this agrivoltaics field. And I think because so much additional solar energy is kind of a given, there's a lot of benefit from this field and from all of the data that's starting to come out. And I think each project contributes something a little different, and hopefully we'll have something useful to say about grazing and solar colocation that can help inform how people are doing this and how solar companies are thinking about their projects and how the people whose land is being leased are thinking about managing their land and working with solar. solar companies rather than kind of losing that agricultural component. So I think there's a lot of benefits to be had from these systems and from the kind of broader systems level thinking.
Awesome. Any other final thoughts before we wrap things up?
I don't think so. This has been great.
Yeah. So our time's up for today. Thank you again, Taylor, for joining us. We do really appreciate you taking the time to talk with us today. It's been a really fascinating conversation here.
Thanks again for having me. This was great.
Stay safe, and we'll see you next time on We Measure the World.